What if the biggest clue to finding gold is hidden in the way a river flows? Most people search randomly, but experienced prospectors know that gold follows predictable patterns. In this video, we'll reveal the small river features that can point you toward real gold deposits. You'll learn why inside bends, exposed bedrock, black sand, and slow water zones are so important. These natural clues have helped prospectors locate gold for generations. Understanding how water moves and concentrates heavy minerals can dramatically improve your chances of success. Stay with us as we break down the science behind river gold and show you exactly what to look for in the field. Let's step into the river and uncover the tiny clues that could lead to your next gold discovery. Most people stand beside a river and notice nothing except flowing water, moving current, ordinary gravel, mud, sand, and scattered stones shaped by time. But skilled prospectors observe something entirely different. They recognize pressure zones, ancient flood behavior, hidden pathways where dense minerals naturally collect over long periods of time. Because rivers do not distribute material randomly. Every bend in the channel, every exposed section of bedrock, every sudden change in water velocity changes where heavy minerals settle. And what makes this even more fascinating, some of the strongest gold indicators are almost invisible to beginners. Subtle black sand streaks trapped between gravel layers, compact sediment hidden beneath larger stones, unusual current seams moving differently than surrounding water, heavy mineral pockets preserved after ancient flood events. Small environmental details most people ignore completely, because experienced prospectors are not simply searching for visible gold. They are studying the river itself. Most beginners imagine gold hunting as pure luck, walking into random water, scooping gravel into a pan, hoping something valuable appears. But professionals understand something deeper. Gold follows predictable physical laws. It is one of the heaviest naturally occurring metals on Earth, which means moving water affects it differently than ordinary sediment. Lighter material gets carried downstream quickly. Fine sand shifts constantly with the current. But dense minerals behave another way entirely. They slow down, they settle, they become trapped wherever river energy weakens enough to release them, which means rivers quietly leave clues long before visible gold ever appears. But here's the surprising part. The hardest part of river prospecting is not recovering gold. It is understanding where the river wants to hide it. Initially, most rivers appear chaotic, fast current, scattered gravel, water colliding against exposed stone from every direction. Nothing organized, nothing obvious. But trained eyes begin recognizing structure inside the movement. Slow current seams forming near inside bends. Heavy gravel trapped behind large boulders. Dark mineral concentration resting inside exposed bedrock fractures. Flood-deposited sediment compacted above the active waterline. Because rivers constantly separate material according to weight and density. And if gold exists anywhere upstream, the river naturally attempts to concentrate it downstream. So the real question becomes, what advanced river clues do experts actually rely on? The answer begins with river energy itself, because gold rarely settles where water moves aggressively. It settles where river force weakens suddenly. Inside bends where pressure drops. Behind natural barriers interrupting the current. Deep cracks in exposed bedrock, where dense material becomes trapped during floods. To most people, these locations appear completely ordinary. A shallow gravel bar, a narrow current seam, dark sediment resting quietly behind exposed stone. Easy to overlook entirely, but experienced prospectors recognize something critical. Even small reductions in water velocity can create major differences in heavy mineral concentration. A slight change in current strength may determine whether gold keeps moving downstream or settles permanently into the riverbed. Eventually, attention shifts toward one unusual section of river. At first, nothing appears remarkable. Water moving steadily across gravel, scattered rocks lining the channel, ordinary sediment stretching along the riverbed. But several advanced clues begin standing out immediately. Black sand trapped deep inside bedrock cracks, rounded heavy gravel sitting beneath lighter sediment layers, a natural pressure drop forming behind exposed boulders, compact flood deposits preserved above modern water flow, and gradually, The river starts revealing its hidden structure because experienced prospectors understand something beginners often miss completely. Modern rivers preserve evidence from ancient floods too. Violent seasonal flooding moves enormous amounts of heavy material. Dense minerals shift during periods of extreme current pressure, and once flood energy weakens, gold settles into natural trap zones that may remain productive for decades, which means today's river often contains clues left behind by older river systems hidden beneath the surface. But even after identifying promising terrain, the gold itself still remains invisible. Careful sampling begins slowly. Compact gravel removed from exposed bedrock cracks. Heavy sediment collected near current interruptions. Dark mineral concentrates separated through controlled panning. At first, nothing valuable seems visible. Only dense mineral grains, dark sediment, ordinary-looking concentrate mixed with river material. And this is exactly where many beginners stop too early, because advanced river prospecting rarely produces instant visual success. The first objective is confirmation, determining whether heavy minerals concentrated correctly, understanding whether flood behavior created stable trap zones, verifying whether the river structure matches productive geological conditions. Because expert prospectors understand something important. The river reveals its secrets gradually. Then something changes. Tiny reflective signals begin appearing inside the concentrate, barely visible, almost microscopic, but impossible to mistake. Natural gold. And suddenly, every advanced clue starts making sense. The black sand, the pressure drop, the compact gravel layer, the exposed bedrock fracture trapping dense material beneath the current. The river was concentrating gold naturally the entire time. Now the investigation becomes more focused. Additional samples collected along current seams. Bedrock cracks cleaned carefully beneath shallow flow. Flood gravel tested higher above active water levels. Heavy mineral zones mapped throughout the river system. And slowly, the pattern becomes stronger. Black sand concentration increases sharply. Heavy gravel becomes more compact. Gold flakes appear more consistently within specific zones. And suddenly, the river no longer feels random at all. Because beneath the moving current, an organized natural sorting system has been operating continuously for centuries. But advanced prospecting changes people mentally too. Because once prospectors begin understanding river behavior, every environmental detail starts carrying meaning. Current speed, sediment layering, the angle water strikes exposed stone, the shape of gravel resting beneath the surface. Small details begin revealing enormous geological stories. Experienced prospectors stop viewing rivers as scenery. They begin seeing them as machines. Natural systems constantly sorting Earth's materials according to size, density, and weight. Then the situation shifts unexpectedly. Fresh samples begin producing weaker signals. Black sand concentration decreases sharply. Heavy material becomes inconsistent again. And this is where many prospectors fail completely, because productive river systems are rarely uniform. Flood behavior changes constantly. River pressure shifts seasonally. Gold concentration moves according to current force and bedrock structure, meaning rich zones can disappear suddenly, then reappear unexpectedly nearby. So the search continues, more carefully this time. Then one advanced clue changes everything. A narrow seam of slower current flowing beside exposed bedrock. Dense black sand trapped deep inside a fracture system. Large rounded stones locking heavy material beneath them. And inside that hidden pressure zone, a much stronger signal suddenly appears. Not one tiny gold flake, several. Larger, brighter, heavier than before. And now, the river's hidden structure finally becomes obvious, because moving water had been concentrating dense minerals into that exact location naturally for years, maybe even decades. The frame tightens over the dark mineral layer resting beneath the moving water. At first, only faint reflections appear between the black sand. Then something remarkable emerges. A brighter gold fragment settles heavily into the bottom layer, dense, clearly visible beneath the concentrate, resting motionless against the darker sediment around it. And for a moment, the river no longer feels ordinary at all, because hidden beneath flowing water, nature created an incredibly precise sorting system capable of trapping real gold. Careful separation continues. Additional flakes appear beside the larger fragment. More heavy concentrate recovered from bedrock traps and current seams. A hidden placer system shaped entirely by water pressure and natural physics. Not discovered through luck alone, but through observation, geology, and understanding advanced river behavior. Because expert prospectors do not search randomly. They study patterns, pressure changes, flood behavior, and the way rivers naturally organize heavy material over time. And this is the key lesson. The advanced river clues experts use are not mysterious. Pressure drops, black sand concentration, bedrock fractures, flood gravel layers, current seams, heavy mineral traps hidden beneath ordinary water flow. Because gold behaves predictably inside moving water systems, and rivers quietly reveal those patterns to anyone patient enough to study them carefully. By now, you've seen that gold doesn't settle in a river by chance. It follows the laws of nature. Every bend, gravel bar, and exposed bedrock crack tells a story that experienced prospectors know how to read. The smallest river feature can sometimes lead to the biggest discovery. In the next section, we'll examine the exact locations where gold is most likely to accumulate. Stay with us, because the most valuable clues are coming up next.
Most people walk right past gold without knowing it. Not because it's hidden deep, because it's hiding in plain sight. A rust-stained crack in quartz, a specific fracture pattern on a hillside, rock structures that look completely ordinary, unless you know what you're looking at. By the end of this video, you'll know the exact signals geologists use to find gold systems underground. And there's one subtle clue in particular that separates worthless rock from real gold-bearing ground. Once you see it, you'll never look at rocks the same way again.
You've walked past this rock your entire life, kicked it, ignored it, maybe even picked it up, then dropped it because it looked worthless. No sparkle, no shine. No sign of treasure. But here's the truth. Most people never realize. Some of the richest gold discoveries in history didn't start with nuggets. They started with this: plain, broken, rust-stained quartz. Ugly, ordinary, easy to ignore. And the reason most people never find gold isn't because gold is rare. It's because they don't know what gold actually looks like before it looks like gold. Today, I'll show you why most quartz is useless. The one type that has produced massive gold deposits, and the subtle clues in the surrounding rocks that quietly point to hidden treasure. Once you see this, you'll never walk past quartz the same way again. So the question becomes, if quartz is everywhere, why does only a small percentage of it contain gold? What separates worthless quartz from quartz that has produced millions, even billions of dollars in gold across regions like California, Nevada, and Alaska? And more importantly, can you recognize the difference just by looking at it? 1. Milky quartz, the most misunderstood. You've seen it before: bright white, solid, clean-looking. Milky quartz is everywhere. So ask yourself, if quartz is associated with gold, does that mean all milky quartz is valuable? No. In fact, most of it is completely useless for gold. Why? Because milky quartz often forms in stable conditions. No major fractures, no fluid mixing, no structural complexity. And without those conditions, gold never had a reason to deposit. So the real question is the quartz just present, or was it part of an active mineral system? Because presence alone means nothing. 2. Iron-stained quartz, the first real signal. Now look at quartz that isn't clean. Instead, it's stained. Red, brown, yellow, almost rusted. So what caused that? Iron. More specifically, oxidized iron minerals, and that changes everything. Because iron staining often indicates that mineral-rich fluids moved through the rock. And those fluids? They are the same type that can carry gold. Now ask, is iron staining proof of gold? No. But is it a strong indicator of a system that could contain gold? Yes. And across many U.S. gold districts, iron-stained quartz is one of the most consistent surface clues. 3. Vuggy quartz. Open space equals opportunity. Now examine quartz with holes, small cavities, irregular openings. This is called vuggy quartz. So what does that mean? It means that at some point, there was space inside the rock. And why does that matter? Because gold-bearing fluids need space to move. And more importantly, space where pressure can drop. And when pressure drops, gold comes out of solution. So now ask yourself, is solid quartz better or fractured, open quartz? Because the answer tells you where gold had the opportunity to form. 4. Sulfide-rich quartz, the hidden gold zone. Now things become less obvious. Some quartz contains metallic minerals, pyrite, arsenoperite, chalcopyrite. At first glance, these don't look valuable. In fact, many people ignore them. But here's the question: why are sulfides important? Because gold often travels and deposits alongside sulfide minerals. In many cases, the gold isn't visible. It's microscopic, locked inside the rock. So now think carefully. Would you rather find visible gold or a system capable of producing large-scale gold deposits? Because some of the richest gold mines in the US started with sulfide-rich quartz that didn't look impressive at all. Now ask yourself, which system is more likely to contain gold? One that formed once, or one that formed repeatedly under changing conditions? Because repetition builds value. And in places like the California Mother Lode, banded quartz veins have produced millions of ounces of gold. At this point, the signs are clear, but most people still fail. Why? Because they look for gold itself. Instead of the system, they search for shiny flakes, visible nuggets. But gold rarely appears that way at first. Instead, it leaves clues: iron staining fractures, sulfides, layering. So the real question becomes, are you searching for gold? Or are you searching for evidence that gold could exist? Let's make this real. Gold today trades at over $2,000 per ounce. Now imagine a quartz vein, just one small section, containing a few ounces per ton. That can quickly translate into thousands of dollars in value. And larger systems? They've produced millions, even billions across US mining history. So when you ignore a piece of quartz, you're not just ignoring a rock. You could be ignoring a system that once carried real value. At this point, something changes. You stop asking, does this rock contain gold? And start asking, was there fluid movement here? Is there structural complexity? Are there multiple mineral signals present? Because those questions lead to answers that are repeatable. Quartz is not valuable by itself. It becomes valuable only when it records the right geological history. Without that history, it's just a rock. With that history, it becomes evidence of a system that can produce gold. So the next time you see quartz, don't judge it by how it looks. Don't look for shine. Don't look for perfection. Ask a better question. What has this rock been through? Because if it shows the right signs, you might not be looking at something worthless at all. You might be looking at the beginning of something valuable. So now you know something most people don't. Not all quartz matters. But that leads to a more important question. If only certain quartz carries gold, where inside that quartz should you actually focus? Because even in a gold-bearing system, most of it still contains nothing. So how do you avoid wasting time on empty rock and focus only on the parts that matter? What tells you, stay here, instead of move on? Pick up a piece of quartz. Is it solid and clean, or broken Cracked? Irregular? Now ask yourself, which one allowed fluids to move through it? Because gold doesn't form in sealed rock. It forms where fluids had access. So fractures aren't damage, they're opportunity. Now look beyond the quartz itself. What is it touching? Is it surrounded by dark host rock schist or altered material iron-stained zones? Because the edges, the contact between quartz and surrounding rock, are often where the most important reactions happen. So ask, are you only looking at the quartz, or the entire system around it? Now pick up two similar rocks. Same size, but one feels heavier. Why? Because gold is dense, very dense, so even small amounts can change the weight. But here's the question, are you paying attention to that difference, or ignoring it? Now step back. Have you seen this type of quartz once, or multiple times in the same area? Because repetition matters. One rock means nothing. A pattern means something. And multiple similar signals in one place suggest a system, not coincidence.
Up to this point, the patterns already look unusual. But this is where things become far more interesting, because not all quartz is important, and not every fracture leads to gold. The next geological signs are the exact details experienced prospectors pay closest attention to before drilling, sampling, or exploring deeper underground. Tiny structural changes, mineral staining, pressure pathways hidden inside the rock itself. And once you notice these signals, you start realizing why some people walk directly past gold-bearing ground without ever knowing it. Watch closely, because one small feature coming up is considered one of the strongest natural indicators in certain gold systems.
Most people think the hardest part about gold is getting it out of the rock, crushing it, reducing it, separating it, and they're not wrong. But here's what almost no one realizes. If you're crushing the wrong rock, you're just destroying stone, not extracting gold. Because before extraction ever begins, there's a more important question. Are you even standing in the right place? In the last episode, we broke down the truth about gold extraction. Gold doesn't sit there waiting to be picked. It's locked inside structure. You have to break that structure, reduce it, separate it, and only then does gold reveal itself. But here's the uncomfortable reality. Most people never reach that stage, not because extraction is difficult, but because they never find the right rock to begin with. And that's where this changes, because gold does not appear randomly. It follows structure, it follows pressure, it follows pathways. And those pathways leave visible patterns. Patterns in the rock, patterns in the landscape. Patterns most people walk past every single day. Right now, you could be standing on gold and not even know it. Not because it's hidden well, but because you don't yet understand the language of the ground beneath your feet. Today, we're decoding that language, because once you understand these patterns, you don't just look for gold. You eliminate everything that doesn't matter. And that's how professionals think. Not, where is gold? But, where can gold exist? And once you ask that question correctly, the ground starts answering. Gold is not scattered randomly through the earth. It moves. Deep underground, long before any rock you see today existed, superheated fluids carried dissolved minerals through the crust. These weren't slow movements. They were high-pressure systems, forcing their way through fractures, cracks, and weak zones. And those fluids carried gold, not as visible metal, but as microscopic particles, dissolved and transported. Now think about that carefully. Gold didn't form where you find it. It traveled there. And when conditions changed, temperature dropped, pressure shifted, those fluids slowed down. And when they slowed, they deposited what they were carrying. That includes gold. But here's the key detail most people miss. Those fluids didn't move randomly. They followed structure. Weak zones in the earth, cracks, faults, fractures, folds. So wherever you find those structures today, you are not just looking at rock, you are looking at the pathways gold once traveled. And where gold traveled, some of it stayed. That's the first rule. Gold follows structure, not surface appearance, not color, not shine. Structure. And structure leaves clues. Now let's move from theory to something you can actually see. Walk through almost any dry terrain, riverbank, mountain slope, and you'll notice something common: rust-colored rock. Red, brown, orange. Most people ignore it because it looks ordinary. But in geology, that color is not decoration, it's information. Iron staining happens when minerals oxidize. In simple terms, minerals exposed to fluids and air begin to break down and leave behind iron oxides. That rusty look is evidence that fluids moved through that rock. And remember what we just established. Where fluids moved, gold could have moved too. This is why iron-stained zones matter. They are not proof of gold, but they are proof of movement. And movement is what you're looking for. Because gold doesn't sit in untouched rock. It exists where change occurred. So when you see iron staining, you're not looking at ugly rock. You're looking at a geological record of activity. And activity is where probability begins. Now we go deeper, because if there is one rock type people associate with gold, it's quartz. But this is also where most people go wrong. They see quartz and assume it contains gold. That's a mistake, because most quartz is completely empty. Clean, white, glassy quartz, usually worthless. Why? Because it shows no evidence of stress, no fractures, no fluid interaction. It formed clean and stayed clean. But gold doesn't deposit in clean environments. It deposits in broken ones. So the quartz you're actually looking for doesn't look attractive. It looks disturbed, fractured, broken, iron-stained, sometimes even dirty, because those features tell you something critical. That quartz was part of a fluid system, and if it was part of that system, it had the opportunity to trap gold. Now connect this to the previous episode. If gold is trapped inside structure, then the only quartz worth crushing is the quartz that shows evidence of trapping. Not the clean pieces, the damaged ones, the ones most people ignore. That's where extraction becomes meaningful. Now we move to something even more powerful. Large-scale structure, because not all gold indicators are small. Some are massive, visible across entire landscapes. Look at a hillside. Do you see layers bent instead of flat? That's folding. Do you see cracks cutting across rock layers? That's fracturing. Do you see displacement, where one section of rock has shifted relative to another? That's faulting. These are not random features. They are the result of pressure. Extreme pressure. And pressure creates pathways. Remember, gold moves through weakness. So when rock is compressed, bent, broken, it creates exactly what gold needs: space to move, space to deposit, space to become trapped. So when you see these features, you are not just looking at landscape, you are looking at potential. This is why professionals don't just scan the ground. They read structure at scale. Because large structures guide smaller ones, and smaller ones are where gold concentrates. Now bring everything together. In the last episode, we focused on extraction, crushing, reducing, separating, but none of that matters if you're not starting with the right material. So now the process becomes two parts. 1. Identify the right structure. 2. Then apply extraction. Most people reverse this. They break random rocks, hoping to find gold. Professionals do the opposite. They eliminate 90% of rocks first, and only crush what has probability. That's the difference between guessing and operating with precision. Now imagine this. You find iron-stained, fractured quartz near a visible fault line. You already know something important. That rock was part of a fluid system. Now extraction makes sense. Now crushing has purpose. Now separation has potential. Without that, you're just grinding stone. There's one more layer. And this is where things become subtle. Because not all indicators are obvious. Sometimes the biggest clue is contrast. A sudden change in rock type. From light to dark. From smooth to fractured. From solid to broken. These boundaries are often where fluids focused, because different rock types respond differently to pressure. Some crack, some resist. And where those differences meet, you get movement. And where you get movement, you get opportunity. This is why transitions matter. Not just what the rock is, but what it becomes. Step back. This isn't just about rocks, it's a system. Gold isn't random. It follows fractures, faults, and pressure zones. And those processes leave signals: iron staining, broken quartz, disturbed structures. Not flaws, evidence. Once you see that, everything changes. You stop guessing. You start targeting. And this is where extraction matters. It's not about crushing rock. It's about crushing the right rock. Anyone can break stone, but without structure, it leads nowhere. Combine pattern recognition with controlled extraction, and you create results. Identify, reduce, separate. If gold is there, it won't stay hidden. Most people wait to see gold. Professionals force it to reveal itself. So next time you see fractured ground, don't ignore it. Because if you understand the patterns, you're not searching anymore. You're finding.